In a new age world filled with delusions and wish fulfillment by morons in need of attention, renowned experiencers of high strangeness and podcasters Jeffrey Ritzman and Jeremy Vaeni received invitations to a tropical paradise getaway called Paratopia. Little did they know, it was the same type of new age spiritual retreat they've been avoiding all their lives. When last Jeremy Vaeni and Jeff Ritzman had a scientist on the show, it went like this.
Something I've always wanted to ask of someone like you. I've wondered at times that based on the amount of devotion or the amount of attention that someone pays to a particular phenomena, and then that person then has that phenomena manifest not only for themselves but for other witnesses in the same, in the same presence of. Do you feel that has any basis in any sort of physics that you could mesh some ideas together and tell me how that works, how that would work?
Yes, I think that's one of the easiest things to understand, and it's in fact probably very closely related to remote viewing. What happens is that it's more like telepathy, where the remote viewer, now that would be you, Jeff, is now able to telepathically communicate with a person in that remote site. And therefore, you telepathically communicate through that person's eyes and consciousness, and you literally tune into what that sentient being or that remote viewer sees. That's the way it would work in the case of remote viewing. Now, it's also true that aliens are able to very finely attune to our consciousness. And it's very likely that when they want to bring a spaceship into our space-time, that's a rather difficult undertaking, and they find it easiest to do that by riding on your wave of consciousness. In other words, they take your wave as being something that's there in space, and thereby they're able to ride on that wave and appear to be seen by you and others around you also, because your consciousness is there and you are the thing that guides in the ship. Doesn't this answer the question in a sense?
Yeah, I'd go along with that. Sure.
Now, months later, they have Dr. Dan Hooper, an associate scientist in the Theoretical Astrophysics Group at the Fermi National Accelerator Laboratory, and an assistant professor in the Department of Astronomy and Astrophysics at the University of Chicago. He's the author of Dark Cosmos and Nature's Blueprint, and his research focuses on the interface between particle physics and cosmology. How will it go this time? What will the boys ask? How will he answer? The answers to these questions and many more await on the other side of this break.
Hey guys and gals, it's Jeff here with a message about Mark Nesbitt's Supernatural Summit, February 19th through the 21st, 2010. This is unlike any paranormal conference you've ever been to. In fact, one of the reasons it's so innovative is that you never leave your home. You attend this online. This is a virtual conference. You can be anywhere in the world with net access, and from a home PC, a laptop, right down to a cell phone, you can attend this gig. You can ask questions live to the presenters, interact with different exhibitors. Every aspect of an in-person conference is there. This is over 50 hours of presentations and interactions with paranormal investigators, authors, and exhibitors, right down to your fellow attendees without the travel cost or hotel expenses. One of the best parts, after this whole thing is over, you've got 4 weeks to watch recordings of the lectures you may have missed during the live event. You're not going to miss anything but the hotel bills, the travel nonsense, and of course your missed work time. There's also exhibitor booths where you can shop from home for books, DVDs, and even investigation equipment. So you're not even missing the tables you normally see at a conference. Some of the presenters, some of the best out there: Rosemary Ellen Guiley, Scott Crownover, Lane Crosby, Dr. Charles Emmons, Rob Conover, John Zaffis, and even the dear friend of this show, Mr. Mark Nesbitt. And that's just some of the great presenters you'll be able to hear and interact with. Now, here's the deal for our listeners. You're saying, what's this cost? Well, the cost, if you mention Paratopia and register before February 15th, the cost is $50. That's $25 off the regular admission for the whole conference. Now, in addition to the discount, Mark's decided to do something even more special for our Paratopia listeners. Again, go to www.supernaturalsummit.com. Mention Paratopia when you register. You'll not only get the discount, but in addition to that, you'll be automatically entered for a drawing to win a night's investigation with Mark Nesbitt and me, Jeff Ritzman from Paratopia. So guys, head on over right now, www.supernaturalsummit.com. Get registered. Again, the date for this is the 19th of February through the 21st of February. Go check it out, www.supernaturalsummit.com.
Well, Paratopia, without further ado, please welcome our very special guest, Dr. Dan Hooper. Dan, thank you very much for braving the paranormal fields and coming on the show with us.
Well, thanks for having me.
I want to start off probably in a slightly different way. I'm looking at Chapter 9 of your book, Dark Cosmos, and you start off with a quote from Democritus that says, "By convention sweet, by convention bitter, by convention hot, by convention cold, by convention color, but in reality atom and void." Are we to take away from this that the ancient Greeks pretty much knew theoretical physics in the way that modern people do?
Well, you certainly can't say that about the ancient Greeks as a whole. Even if you just limit yourself to the ancient Greek philosophers, I think it's a minority opinion who would have had Democritus' view of atoms and emptiness. Democritus, of course, is quoted a lot now because he happens to be the one who was right. But there were a lot of the ancient Greeks who thought that matter was fundamentally continuous and you could break it into as many pieces as you chose to. And in contrast, Democritus somehow figured out, or at least had a hunch, that if you broke down a piece of matter, into small enough pieces, eventually you'd have fundamental units. He called them atoms, and you couldn't make them smaller than that. And he was right in that respect, but many of his contemporaries were wrong.
Okay. Yeah, I just thought it was interesting because it struck me that, we have this vision of science really starting around, Galileo, Newton, somewhere in there, and theoretical physics really around Einstein, I think, is just sort of the layman's view of things. And it just struck me, did we lose a thread of scientific inquiry because of maybe the onset of rampant Christianity or something? I mean, what happened between ancient Greece and Einstein that there's
well, certainly the decline and fall of the Roman Empire and the 1,000-year span that lasted from that moment until the birth of the Renaissance and Enlightenment. Very little scientific progress was made in that vast stretch of time. So if the wealth and economics of Europe had maintained itself over that period, surely we would have advanced more scientifically. But sadly, that was not how things played out.
Okay, and maybe you can just help us with some basic definitions of things. I'll just ask you, what are dark matter and dark energy?
Sure, so let me just start with dark matter. So if you just take a survey of the space around you, you probably are sitting in a room somewhere, and you see walls, and you see objects, you see, I don't know, in my case, I see books, I see musical instruments, I see a table. All of these things, include in my body, the air, everything are made of atoms. The stuff you find in the periodic table, the stuff you learn about in high school chemistry. But as cosmologists and astrophysicists measured various bodies in the universe with greater and greater precision, they found that most of the stuff wasn't made of atoms. Most of the stuff they find is now some sort of very weakly interacting or inert substance that we can only tell it's there from its gravity, and we call that, for lack of a better name, dark matter. We don't really know what it is, but we know it's there. Mm-hmm. And then dark energy is weirder still. Dark energy, in a nutshell, is the quantity of energy built up in empty space. And this energy causes the universe to grow at an ever-quickening rate, or its expansion rate to accelerate. And again, we don't know why it's there. We don't really know what causes this energy to be present, or especially not in the quantity we find it in. So these are two of the biggest mysteries we have in modern cosmology.
And, all right, one more definition. What is the anthropic principle?
Okay. So back in the 70s, philosophers started talking about this thing. They now call the anthropic principle. And the basic idea is this. If you have a universe, and you're living in the universe, and you're aware of the fact that you're living in that universe, then that universe must have the conditions that, make life possible, or complex organisms possible, in the broadest of all possible definitions. So this doesn't seem to be a statement that has a lot of information. Of course, if you're cognizant of something, then life had to be present in that universe. That seems pretty obvious, but it has pretty profound implications. In particular, if you found that your universe had some very, very unlikely property, some very, very delicately balanced quantity that just made life possible, and if that quantity were a little bit bigger, a little bit smaller, life wouldn't have existed. You might invoke the anthropic principle to say, well, if it had been bigger or smaller, we wouldn't have been here. So, of course, we're observing the special universe in which life is possible, but we shouldn't be surprised by that. Where that ties into dark energy is that it turns out that theoretical physicists calculate how much dark energy should exist in the universe, and they get much, much bigger numbers than we actually find to exist in the universe. Mm-hmm. And it's something like 10 to the 120 times too much stuff. If you just contemplate that number for a second. 10 to the 120, that's a 1 followed by 120 zeros. It's hard to think of anything that there are 10 to the 120 of. It's a truly mind-boggling quantity. But theoretical physics seems to suggest that in most universes there should be 10 to the 120 times more dark energy than we find. So, the anthropic principle to the rescue. In all of those universes with all that huge quantity of dark energy, you couldn't have life. You could not have had life because it would have grown so quickly and so violently that no complicated structures would have formed. Mm-hmm. So, of course, we find ourselves in the lucky universe with very little dark energy. That's how cosmologists like to use the anthropic principle.
So, if we were to shine a flashlight and be able to see dark matter, would we see an ecosystem there? Would organisms or life forms be able to exist in dark matter or comprised of dark matter?
Well, probably not, but we can't be completely sure. What we can say for sure is that when we do a computer simulation of how dark matter particles would behave, we usually assume that those particles are slow-moving and what we call collisionless. By collisionless, we mean they practically never bounce off of each other or clump up or anything like that. They just interact by gravity. They don't do anything else. And when we run those computer simulations and we span the duration of the universe's lifetime, we find that, in fact, the dark matter forms bodies that look a lot like galaxies and clusters of galaxies, etc. In other words, it looks like the world we see. So, cold, collisionless dark matter seems to fit all of the observations very well. Collisionless particles don't make organisms or other sorts of structures because, unlike, say, atoms, they don't interact with each other. They just are ambivalent to each other's existence. They don't care about any of that. They just move in their straight lines and get tugged on by gravity and tug themselves through gravity, and nothing else happens. On the other hand, some people are thinking more and more these days about dark matter that has their own forces that dictate their behavior. And maybe in these sort of hidden sector models where the dark matter lives, you could have more complicated stuff. Although that's kind of a new idea and one that certainly hasn't been demonstrated to be true yet.
So what's the difference between dark matter and mirror matter?
Okay, well, mirror matter is, basically the idea behind mirror matter is as follows. So we have this beautiful standard model of particle physics that describes basically all the stuff in our universe except for gravity. And mirror matter says there's an exact copy of those laws of physics, but the two copies don't talk to each other. So there are two kinds of electrons that can exist, the kind we see, and then another kind that we call a mirror electron. And there's a proton, and there's a mirror proton, and there's a quark, and there's a mirror quark, etc. So everything's got its mirror version. And this mirror version interacts with other mirror particles ordinarily. So you might have mirror atoms, and you might have all the sort of phenomena we see in our universe, but in the mirror universe. And all this is on top of each other, except the two worlds don't really talk to each other directly except through gravity. So we don't really notice it very well. Certainly mirror matter isn't the kind of theory that most physicists think is likely to be true, but it's one of many theoretical ideas that we've thrown around as possibilities, and we conduct experiments to test.
Would mirror matter include mirror activity?
Sure.
Are we talking about like universe, a bizarro world of bizarro us's?
If you tweaked everything just right, you could imagine writing down a theory where there were mirror stars and mirror planets, and on those mirror planets could be mirror life and all sorts of mirror things. However, they would have probably followed a different path of natural selection, if that happened at all, and the kind of life would be different. And the odds that the mirror universe would be that similar to the real, to our experiential universe is probably pretty thin. So I wouldn't place any bets on, bizarro, myself being in the mirror universe. Mm-hmm. I'm not worried about that.
And I know this is just sort of a rushed, like, hey, what's this? But I swear I'm going to get to a point soon. But can you describe for us non-locality?
Non-locality, that's a tough one.
In terms of the observer effect, how about that?
Yeah. So let's go back to quantum mechanics and all that stuff. So I actually gave a lecture on this very topic on Saturday to a group of high school kids at Fermilab. They were a great audience, and if one of them's listening to this now, I'd like to compliment them on their wonderful questions, and it was really a great experience for me. But okay, let me go back to the topic. So if you take the equations that describe quantum mechanics, which is the laws of physics that describe the subatomic world very well, these equations were written down in the 1920s and 1930s, and they have some peculiar properties. If you follow them to their logical conclusion, it suggests, for example, that particles aren't in one place at one time, or they don't have one well-defined speed, they don't have one quantity of energy, and the time at which events take place isn't really singular, it's spread out over time a little. So all of reality at the quantum level is very, very fuzzy. It's not well-defined, and the edges are unclear. So if you take this to its logical conclusion, it turns out that when somebody observes a quantum system, so say I measure where a particle is, I can measure where that is, but in the end you wonder, well, how did that particle, which was once distributed over this range of locations, suddenly find itself in one location? One interpretation of this result, called the Copenhagen Interpretation, says that the act of observing that particle causes its distribution, called its wave function, to collapse into one point. And then you observe it in that one point. So here the observer plays a very special role. Another interpretation is called the many worlds interpretation, and it says that no, that doesn't happen at all. Beforehand, there was an electron in point B and an electron in point A, and you observe it, and there's an observer version of you seeing it in A, and now there's an observer version of you seeing it in B. So, in fact, the quantum universe entails multiple kinds of observers experiencing different things. So, in other words, there's many versions of you in various quantum versions of reality. Mm-hmm. Where non-locality comes in is it turns out that you can do away with all of this if you want to. If you say that, well, no, there's this whole other set of quantities in the quantum world, we don't really know what they are in detail, but somehow in this non-local way they get communicated back and forth, and all these weird paradoxes go away. And what I mean by non-local is that you can send information between quantum particles at instantaneous speed, faster than the speed of light. Mm-hmm. And that solves a lot of paradoxes, But then it introduces a bunch of paradoxes of its own, and physicists, for the most part, don't like non-locality. It definitely makes our world harder to understand and possibly just logically inconsistent.
I didn't know that. Is it possible that what's really going on is that the observer can't observe nothing, and so they by default end up creating something to see, so you're
invoking an anthropic argument into quantum mechanics to solve the problem.
Yeah, what do you think?
Well, I mean, according to quantum mechanics, it's never that you have nothing to see. It's that you're picking among an ensemble of possibilities. The question is, which one of those possibilities do you see? In determining which of the quantum possibilities actually takes place to an observer, that's in the real challenge of quantum interpretation.
But wouldn't the fact that it reacts according to the observer's expectations imply that it's somehow being concocted by the observer?
Well, the question I would raise to somebody with that hypothesis is this: so an observer, what is an observer exactly, and what makes it in and of itself able to alter reality in a way that other material doesn't? I'm an observer. I'm pretty sure I'm an observer, but I'm also pretty sure I'm made up of atoms, and I'm basically a complex organism, but I don't understand why my act of measuring the location of an electron forces it to one location, collapses its wave function, if you will. Well, nothing else does. What is special about me as an observer that enables me to do that? And then you raise questions like, can my pet cat collapse wave functions, or can my computer, or can a mosquito that just bit me, or what an observer is becomes a very ill-defined thing. Mm-hmm. And it leads to a lot of questions without clear answers.
Right. I know in your book Dark Cosmos there's a little bit in a chapter about sort of far out people with far out theories thanking you for validating them, which I enjoyed. But then it got me thinking.
I believe that they weren't thanking us as much as claiming that they had all along said that they knew what we had just written about.
Of course.
I believe the letter was signed Slaughter Engineering, and they knew about dark matter much long ago before we had ever started thinking about it. They wanted to make it clear to us.
Well, this gets me to the Dalai Lama and Buddhism, which is the Dalai Lama is certainly very interested in physics, and I know there are whole Buddhist sects who are sort of saying that this validates what they say about oneness and all of that. Do you find there to be a true correlation there, or do you think it's too tenuous to know? And has the Dalai Lama actually contributed anything to the body of knowledge in physics, as far as you're aware?
Well, as far as I'm aware, he hasn't made any contributions. That being said, I, for one, appreciate the fact that he's interested in it, which is relatively unique among, I would say, major religious groups around the world. You don't find the Pope expressing a great deal of interest in quantum physics. But, I'm not sure that means that the Dalai Lama has, contributed to our body of knowledge. But that's okay. A lot of great people have not contributed to any particular body of knowledge. I haven't contributed to the, Buddhist theology body of knowledge, and I would hope the Dalai Lama wouldn't slight me for that. Mm-hmm. Now, I've read some of the Dalai Lama's writings on this topic, and I don't agree with everything he says, but, for the most part, I'm pretty happy to hear he has a reasonable handle on these ideas, and he expresses them pretty eloquently. And I agree that there's a lot to be drawn philosophically from the discoveries of the 20th century and quantum physics in particular.
Mm-hmm. It's funny because Jeff and I, we talk about paranormal stuff or what quote unquote. And we try to parse out and sort of woo-woo New Age beliefs from what we can actually almost verify. And it seems like that sort of one of the differences is that in order for something to be legit, it has to speak several different languages. It can't just be somebody saying they had an experience. There has to be correlations in science. And even then, it's still up in the air. So let me just throw this at you, and you can Yay this or nay this. You can settle this for me right now. People talk about the third eye. Mystics and enlightened people throughout the ages, or allegedly enlightened, talk about this third eye whereby they can, see other realities or see more of what's in reality. And then biology comes along and discovers that the pineal gland, which happens to be suspiciously located, where the third eye supposedly is, the pineal gland regulates DMT production in the human, and DMT is the hallucinogenic substance found in mushrooms and found in various plants that shamans use and some of these enlightened folks. So we have that in our body. The pineal gland regulates it. Dr. Rick Strassman and Dr. Dennis McKenna, who studied DMT, have come to the sort of tenuous conclusion that hallucinations aren't hallucinations, that they're actually tuning into these other frequencies, right, using DMT. And that's what we really mean when we're talking about a DMT hallucination. It's tuning into other frequencies. In order to do
what do you mean by other frequencies? Tell me exactly what you mean when you say tuned into other frequencies.
Well, I think they sort of leave it open that there are these other sort of freestanding realities that you can interact with in some sort of virtual way through DMT production, or use. And I guess my question would be, in order for that to be true, then they're calling DMT the spirit molecule. Then this spirit molecule, would it not have to have an ability to take one's perception non-local? Is that what we're talking about? Or can I not say that? Am I not allowed to use that term non-local because I don't know what I'm talking about because I'm not a scientist?
Well, I'm not going to be the physics police and tell you what word to use or not. So that's not my job. But let me shed some of my skeptical first reactions to this line of inquiry. First of all, just before we get into the details of how the brain chemistry works in this particular application, there are many cases where some ancient religion or philosophy has made a claim that was sufficiently ambiguous that eventually modern science came up with something similar, and they tried to step in and say, "See, we knew that all along." That's pretty common. You can find this in countless examples of various soothsayers and people with prophecies who manage to be right at least through a certain vantage point. If you make prophecies that are as vague as a Nostradamus, say, eventually lots of them will turn out to be right in a certain sense. And for that matter, if I go to my local Chinese restaurant and open my fortune cookie, there's a pretty good chance I could see some truth in that fortune cookie. It doesn't mean that the makers of that fortune cookie have any deep insights into the world. It just means that they're being sufficiently vague and people are sufficiently imaginative to interpret those things in a way that relates to their world. Mm-hmm. I don't think that these sorts of arguments make for compelling proofs of any science. So now turning to the brain chemistry, regardless of what kind of molecule is present in any particular part of the brain, it's hard for me to imagine how that collection of protons, neutrons, and electrons is going to access any kind of reality that is different than the space and time that we know and the particles that live in that space and time. It's very easy for me to imagine how a type of molecule might project ideas into a human being's brain, and that might be reality to some people, and that's fine. Imagination is not unreal; it's a very real thing. But to prescribe a physical dimension to it or a physical interpretation to it, I don't think the evidence supports that at this time.
Well, I guess it's easier for me to imagine things because I don't actually have the knowledge to back up what I'm imagining, so I can't really yay or nay it. But I'm just going to imagine one more thing at you, and then
sure.
you can act as that for me, which is why I love having you on the show. If a particle is made up of particle-wave duality, would it not just be a matter of having some sort of molecule that somehow grabs our attention, grabs our perception, sort of switching into wave state and merging back into the ocean, which is essentially non-locality, and bringing our perception to some other locality? I mean, isn't that sort of what if possible, psychic ability would get at, or something along those lines. That there is some sort of information field or some sort of non-local state that you could access with your perception and end up in another locality, not physically, but mentally.
So I said before that physicists don't like non-locality. They lead to paradoxes. Mm-hmm. Let me give you an example of what non-locality would bring about. If the laws of physics were non-local, what kinds of things might go wrong? So according to Einstein's theory of special relativity and also general relativity, anything that travels faster than the speed of light, you can look at in some other frame of reference as something traveling backwards in time. They're completely the same statement. If something travels faster than the speed of light, it also travels backwards through time. They're the completely same claim. So let's say you had something that could travel backwards in time. Then I could build a machine that's based on this principle, and I could use it to send a signal backwards in time, informing somebody to go and kill my grandfather before he met my grandmother. At which point I would cease to exist, and I would not build the machine, which of course leads to this paradoxical loop. That anyone who's watched Back to the Future recognizes, occurs in time travel, at least backwards direction time travel. So any and this goes for any kind of non-locality you might introduce into the laws of physics. If you want to introduce non-locality, which again there's no evidence for, you can do so, but only at the expense of making the logical self-consistency of your laws of physics break down. I'm not prepared to do that. If the data someday forced me to, well, then we work on these paradoxes more and maybe try to find a solution. But the data don't suggest we need to. Mm-hmm. And I suspect our universe is, in fact, quite local.
And I guess I have one final question, and it's sort of random. We had Dr. Rudy Shield on from the Harvard Smithsonian Astrophysics Lab.
What did you talk about with Rudy?
We talked about some of this stuff, but well, let me ask you this. He said this, and I'll ask you what you think about this. And I hope I wrote down enough information that you don't ask me what I'm talking about.
Right.
But he said that basically he is able to show, based on his observations of the gravitational lensing around a quasar, that the universe is observable at 2 points at two different times at the same time. In other words, he can observe the universe at this one spot in the sky at 2 different points in time, thanks to gravitational lensing. Does that make sense to you? Is that something that you're able to observe, or is that something he came to on his own?
Oh no, that's perfectly reasonable. The idea is this. I mean, I can give you a much simpler picture where you can observe the same point in the universe at 2 different times. So you stand in a room and you make a collection of mirrors that reflect the light from an object a couple of times, say, and then back to you. And now you look at the object and the reflected light from the object at the same time. Because that light bouncing around mirrors took a while to get to you, you're actually observing that object, say now, and a slight instant before now. There's nothing profound about that. It's just a matter that some of the light took a little while to get to you. The same principle is true with gravitational lensing. Gravitational lensing is just gravity deflecting light. So you can look at, say, a quasar or some other distant object, and some of the light might come, say, straight towards you, and other of the light will get bent away and towards you, so it still reaches you, but not in a straight line. So that comes a little bit later. Mm-hmm. So this is interesting for astronomers because they can look at some quasar or something and and not just see it at one moment in time, but see it at 2, and try to understand how that object's evolving and changing. Whereas it's not that interesting when you just do it with mirrors in your own room.
Well, and I think he went on to then say that you could take this knowledge and sort of apply it to certain things in the paranormal, ghosts or ESP, that sort of thing. You think that's a bit of a stretch, or do you think there's something to that?
No, I don't think there's a lot to that, to be honest. People have, for various, philosophical or religious reasons over thousands of years, imagined that there was a true separation between the spiritual and physical. Nothing in my experience suggests that anything outside of a physical dimension of reality exists.
Huh.
And that means things like ghosts and things just don't have a place in my worldview.
Okay. Well, before I pass over to Jeff, I know that you study dimensions, right?
You mean dimensions of space? Is that? Yeah, sure. I've written quite a few academic papers on the possibility that our universe might have more than 3 dimensions of space.
Would those dimensions be populated with anything, or what does that mean to us? If we could actually see another dimension, what would we see?
Well, there are lots of different types of models with extra dimensions, and it's hard to be too general, but I like to describe most of these using this classic book. Have you ever read this book called Flatland by Edwin Abbott?
No.
Okay, so this was written something like 100 years ago, maybe 110 years ago, by this mathematician. And he described a group of beings who lived in 2-dimensional space. And their world were populated by beings that were things like circles and squares and triangles, but they all lived on a plane, so they could only see each other edge on. And not only did they not know a third dimension of height existed, but they couldn't imagine it. It was completely beyond their intuition or their casual way of thinking. Mm-hmm. So imagine that something like that's true for us. We live in this apparently three-dimensional world with the height, length, and width. But let's say there's a 4th dimension, and we're just not capable of perceiving it for some physical reason. Well, you could imagine, for example, that there could be particles that appear very stationary to us, but are in fact moving through that extra dimension very fast, very quickly. And Einstein says that equals mc squared, so things that are moving quickly have a lot of energy, E, and because we don't see them move, it just appears to be M, mass. So we see heavy versions of particles that appear stationary, but are in fact moving very, very quickly in an extra dimension. That's the kind of thing that physicists are looking for at particle accelerators to try to test the hypothesis of extra dimensions.
Wow. Well, he said when he didn't believe in ghosts that pretty much blew every question I had. No,
sorry to be such a party pooper, you know.
No, not at all, not at all. I mean, Dan, I'm curious. Like when you talk about the extra dimension stuff, and this is something that I've talked to Jeremy a lot about. If we ever had a physicist on, that I would ask. If in fact there are parallel universes and extra dimensions and all this sort of thing, and there are inhabitants of those places. You mentioned that earlier that whatever these forms of life be, they may not look anything like us because they've essentially traveled a different course or taken any number of different paths than we did, and therefore evolved completely differently. In that sense, if there are inhabitants of these places, could they get here?
Well, it depends on what kind of setup you're considering. And the simple case that I just described a second ago, it's very unlikely that any kind of complicated structures of any kind could form. But I could imagine a different kind of world where, say, there's this 3-dimensional world we live in, and kind of simultaneously on top of it is, say, some other 3-dimensional world. But to get between the two worlds, you can only talk through the force of gravity, which is very, very weak. You might not realize this because it feels strong to us, but the force of gravity is much weaker than any other known forces in the universe. The reason it feels strong to us is because we have a really big ball of mass next to us called the Earth. But you might notice that, you know, my hand doesn't gravitationally attract to any objects I pick up. You know, it's because gravity is basically irrelevant as a day-to-day force, except from the Earth. So let's say these two universes that happen to exist right on top of one another can only talk to each other through gravity. Then we'd never know it's there, not in any practical sense. But if there was life in the other 3-dimensional universe, and that life got sophisticated to such an extent that they could manipulate the force of gravity and start sending gravitational signals to us, then yes, we could interact and we could communicate. That is profoundly, mind-bogglingly difficult technology to imagine grasping, but it's something that you could imagine a technological society accomplishing someday.
Would such a communication almost be mirage-like if it existed, or if it could be done at all?
Well, what do you mean mirage-like? What do you mean by that?
I don't know how familiar you are with the whole UFO thing at all, but my own stance on this.
Not very.
Okay, well, my own stance with it is that I am ultimately skeptical that it's anything extraterrestrial, as most people think. I think that it has probably, and I say this only based on my own personal experience, I don't take this from any book or anything of that sort, but there almost seems to be an ability on the sense of the phenomena that it can be physical when it chooses to be, but can then choose not to be. In other words, it almost exists as a mirage of sorts that is visually perceptible to us, but there is no real tangible thing. You can't hit it with a rock, in other words. And I'm wondering that if there is some other life in some other dimension right next door, and they're getting here, and people say they're getting here in ships, or they're getting here in flying saucers, or whatever kind of overlay you want to put on that, I have to wonder if what we're seeing is not mirage-like, and therefore the reason that there is absolutely no physical evidence of any sort of other in 60-plus years of modern ufology. I mean, we have not a shred of anything, and I think that speaks to something that's not physical. That's not to say it's not real, but then we have to go into that definition of what do we mean by real, and that's kind of where I lose my grasp on exactly what the hell I'm talking about. I don't have any kind of background in physics whatsoever, but I wonder a lot that if these beings from possibly some other dimension can't get here, but they can send images. I mean, is that a possibility that what we might be seeing is a mirage from somewhere else that's right next door?
So let's imagine that there's this parallel universe, and there's the life, the highly technologically evolved life on that universe is sending gravitational signals to our three dimensions of space. Those gravitational signals could not inconceivably appear in our universe and cause some sort of observable phenomena. Mm-hmm. That's all physical. So I mean, you said that it's something that's not physical. As a physicist, everything is physical. That's my worldview. That's the sum of everything. So if I use the word real, by real I mean physical, and by physical I mean real.
Hang a rock,
so,
right?
But this is all perfectly physical. What I'm describing, that this gravitational signal and observable phenomena that might appear as a consequence. And by the way, we share at least one worldview in common. I think it's very likely that life exists in other worlds. I don't know that I think it's likely that it's nearby or say has visited us. But
right.
I find it basically almost impossible that life hasn't formed in other environments in our very
Sure.
vast universe.
Sure. I mean, the big question is it coming here? And my thought has always been no.
But then again, if you had a society in some distant planet who had the technology to actually come to our humble little solar system, it would probably have sufficiently great technology that it could conceal itself from us without any difficulty.
True. Right.
So, I can't rule that out.
Yeah. Well, I guess it
I would think hiding from us would be pretty easy.
Well, yeah. I mean,
some other part of the galaxy.
Sure. I don't think that'll ever be off the table. I mean, it's off the table for me, but I don't think it's. I don't think for the majority of the paranormal community it's ever going to be off the table. Now, you mentioned ghosts as not being something that you're that you think much of in the way of that. However, I still have to ask this question: if there is let's say, 3 people standing in a room, and they witness a translucent figure walk through the room, and everyone observes it, and everyone sees it, and they all don't talk, and they all sit down, and they write down what they saw, and everybody saw the same thing. What do you put that down to?
I don't know of the exact circumstance that you're describing.
I mean, any observable, I could name half a dozen UFO cases that are, that I could think of that have multiple observers seeing something that is doing something that is, by all rights, and I'm sure in your profession is or would be considered absolutely impossible to do. Objects in the sky going from a dead stop, hanging completely motionless, to the wink of an eye, it completely disappears. Metallic objects. 3 people see the same thing, 4 people, however many you want to name. I mean, there's been as many as 100, I'm sure, in some cases. I mean, what do we put that down to if everyone is seeing and describing the same thing? And, I mean, do we put this down to all sorts of things like mass hallucination or suggestibility or... I mean, where do all those excuses run out, and what else could it be, in your opinion? I mean, all of these reports, I mean, from all these different people across every walk of life, across every profession you could think of, including scientists, I might add. How long can we go just saying this doesn't fit into the box, and so therefore it can't be?
Well, it's not very hard to find groups of people who will claim to know things that are just simply, factually not true. Uh-huh. You can find people who believe in all sorts of wild conspiracy theories, and they have their reasons, and they will, list them in vivid detail. But it doesn't mean they're right. And the fact is that there's been no compelling evidence in my experience towards any kind of any of the class of phenomena I think you're describing. Mm-hmm. There have been a lot of various videos of Bigfoot and UFOs and things like this that have surfaced and been claimed over time, and they're notoriously fuzzy and difficult and or explicable, or the strings get revealed at some point and things like this, and I just don't think it's that far big of a stretch to imagine that combined with some elements of suggestion or some elements of just general human psychology could explain all of this phenomena. On the other hand, we live in an incredibly complex world with a lot of very counterintuitive and strange features, and I don't want to make these claims to detract from the wonder and the absolute fantastic nature of reality. Reality is amazing. It's I was talking about the strange features of quantum mechanics before, the strange features of relativity. These are by no means less fantastic than UFOs or ghosts or anything like this. This is mind-blowing stuff. So I think we live in an incredibly wondrous universe, but at the same time, the wonder that I've experienced in the universe can be understood, if not explained, by science. Okay.
And the last thing I have for you is something here about the, and this will probably fall right into the woo basket for you. The CERN time travel sabotage, which has come up in the news kind of recently, and I'm
with the Large Hadron Collider. Yeah.
Yes.
Yeah, sure.
Yes. I've got this man here, Holger Beck Nielsen of the Niels Bohr Institute in Copenhagen. Apparently, he's suggesting that that the particle that the physicists hope to produce with that collider might be abhorrent to nature. And when asked what that means, he says that essentially what it means is that the creation of boson. Am I saying that right?
The Higgs boson, yeah.
Right. At some point in the future would then ripple backwards through time to put a stop to whatever created it in the first place. And he said that could explain why the LHC has been hit by so many mishaps, ranging from an explosion during construction to a second Big Bang that followed its startup. And then there was a recent arrest of a physicist who had links to Al-Qaeda and all of this stuff. And I've since heard something about a bird dropping a piece of bread in it that stopped it from working. I mean, I don't know how true any of this stuff is, but I was like, yeah, I got a physicist on the show.
I think you've got all your facts right. In fact, the Large Hadron Collider, which is the world's biggest and most sophisticated particle accelerator, has had a number of technical problems. It's running fine now, by the way. But it last a year ago, September, it had some problems with the magnets, and that led to about a year's delay. And it's up and running now. But yeah, there was a brief delay when, yes, a bird dropped a piece of baguette bread into the apparatus and things like this. But you know what? This is the most complicated machine human beings have ever made.
Sure.
You have to expect a few bumps along the road. And it is running now, and the world has not ended, and it in fact won't. I'm quite confident in that. And I think this Nielsen idea is, somewhere between eccentric and crazy. I'm not sure exactly where in that continuum it falls. But not many of my colleagues are concerned about this particular hypothesis.
Well, what are they with the LHC? What if it's running now? I mean, we were told that there would be these amazing discoveries that would come out of that. I mean, does that kind of thing just take an absurd amount of time, or is this, are they going over what's happened so far with it? I mean, where is all that going right now? I mean, what are they doing?
Sometimes physicists can be a little overzealous about their experiments in the sense that they communicate to the public that this thing's about to turn on and it will change the world, and they don't mention that, oh, by the way, it will change the world in 4 years when we have enough data and have it all analyzed.
Oh, okay.
In fact, it can take a while. The plan right now is that it's going to run in its current configuration. Well, it will turn up in energy a little bit, but it will go up to about half energy and then run for something like 2 years. In that time, there's a pretty good chance we'll be able to discover new physics, whether that be some kind of supersymmetric particles people talk about or something else. There's a fair chance of something happening that we can get really excited about in that time. Then there's going to be a shutdown. They're going to do some maintenance. They're going to do some repairs. They're going to do some improvements. And then they're going to run again. And then hopefully they're going to run at the full energy, the design energy. And at that point, a couple of years into it, there's no reason that we shouldn't expect very great things from the Large Hadron Collider. It is truly the experiment of a generation of physicists. And if things go half as well as we imagine they might, we'll have entirely new paradigms on our hands to contemplate and think about.
Could this conceivably tell you everything you think you know is wrong?
We hope so. That's what
is that the goal? I mean,
right?
Right.
If you look at the history of science, there are a few times where I look back and say, I wish I'd been a physicist there. And one was the 1920s, and when people started figuring out quantum mechanics. And it showed for the first time that everything that physicists had believed since Isaac Newton had been, well, not wrong, because it's a pretty good approximation, but it doesn't really apply to the small scales of our universe. And all those things that physicists have been talking about for the hundreds of years prior were really just kind of close. And it was this whole new world of the quantum ideas, which are just mind-blowing. Right. There have been a few other times, in the 1500s and 1600s, you went from a transition where you had a very different kind of world. You had a very Earth-centric. You had the Earth's the center of the universe, and things fall toward the Earth, and everything out there in space is made of something different than the stuff on Earth, and you had a very Middle Ages kind of worldview of the universe. And then guys like Galileo and Copernicus, Tycho Brahe, Kepler, Newton, all came along in a relatively short order, turned everything on its head. I want to be alive as a physicist when that kind of transition happens. And if the Large Hadron Collider shows us that everything we know is wrong, you would not find a happier person than me than that day.
Well, again, seeing as you're a physicist in the trenches, so they say, what is your opinion, and I've wondered this about a couple of people, actually, of Michio Kaku?
He's written some great books.
Uh-huh.
I remember reading Hyperspace when I was in college. I loved that book. I haven't read it since, but yeah, it was a fantastically inspiring book.
And do you find his different theories and discussions on alien life, whether it may be from a higher dimension or a extraterrestrial source, and how they might get here and all of that? I mean, do you find that all very interesting, albeit theoretical? I mean, do you find it, is that something that you're willing to consider at all?
So I have to admit that I haven't kept up with his recent pondering, so I really don't know enough about it to comment.
Okay.
Michio Kaku seems to be a smart guy, and certainly is a great communicator of science. So I want to give him the benefit of the doubt, but without having read his recent material on those topics, I really can't say much more.
Okay. And I recently saw something on Mr. Hawking's. You know, back when I was a kid, he was the cream of the crop. He was the guy that was really doing amazing work, and everybody knew that name. And nowadays, it seemed like a lot of this program were a lot of people seriously second-guessing the work that he's done, questioning one of his largest theories, and apparently he, too, saying that he could possibly be wrong. And can you explain to us what in the hell he is talking about?
Well, I mean, the single most famous, and almost everyone agree, the most important contribution that Stephen Hawking made was in understanding how black holes radiate. And the idea is this. So before Hawking, you had this notion of a black hole, which is something that even light couldn't escape. And obviously something that light can't escape, well, then there's no radiation from it. It just sits there, and maybe things fall into it, but nothing ever comes out of it. Hawking was able to show that, in fact, it's not really true. Particles can appear in pairs near the edge of the black hole through the laws of quantum mechanics. And one of those particles can fly off into the black hole while the other one flies away. And then that particle that's flying away can actually escape. So this leads to this radiation called Hawking radiation. And it helps us understand the nature of black holes in a very wide variety of ways. Now, there certainly is some underlying skepticism, but this is reasonable given the fact that, we've never observed Hawking radiation from a black hole. We've never had a telescope that's been powerful enough to notice that sort of phenomena. So, until we actually observe it, we can't be sure that this is really how things work. Okay. More recently, Hawking has made an announcement that he solved something called the information paradox, which is a matter of if you drop something into a black hole, is the information encoded in that something erased forever, or can you get it again? Can you learn that same information again if you look at the Hawking radiation that comes out of the black hole? And for a long time, this wasn't a really resolved issue, and Hawking presented a proof at a conference in Ireland a few years ago. And last I heard, and I haven't followed it that carefully, but last I heard, the community wasn't completely convinced that he was right, and there was ongoing debate about this. But even if he turns out to be wrong about that, his contributions to black hole physics, I don't think will be reversed. I think he'll still have a great legacy.
Yeah, Jeremy, go ahead.
I'm just wondering, what is the Hadron Collider doing that the Fermi Collider doesn't do? What are the differences?
Well, okay, so at Fermilab, where I work, we have our flagship collider is called the Tevatron. It has just under 2 tera-electron volts of energy. And what I mean by that is when we collide a proton and an antiproton together, they collide, and that individual collision has about 2 tera-electron volts of energy. At the Large Hadron Collider in Switzerland, they collide protons with protons, and each of those collisions, when at the full energy, will have 14 tera-electron volts, so 7 times more energy than we have. That means that, roughly speaking, you can produce things that are 7 times heavier or 7 times more massive than we can, which means you can produce all sorts of kinds of new forms of matter that we've never discovered before. At least that's the hope. Mm-hmm. So, I mean, this all comes down to Einstein's equals MC squared. If you want to produce things that are heavy with a lot of M mass, you need a lot of energy, E. And frankly, the Large Hadron Collider just has a lot more of it than we do.
Were you jealous? Were you like, oh man, I wish we had that Hadron Collider?
Oh, I'd love to have a Large Hadron Collider. I mean, the hope is that this is just a bit of a cycle, and yeah, for the next decade or two, Europe will be doing the Large Hadron Collider, reasonably exclusively around in terms of particle physics around the world. But then the Americans will build a new machine, maybe a muon collider, for example, and this will be the next big thing after that. In the meantime, though, the Fermilab Tevatron has some real great, really exciting prospects for discovery. The Higgs boson, which we mentioned before, is getting close to our reach. It wouldn't surprise me if in a year or two we see our first signals of this particle.
How do you judge that? How do you judge that you're getting close to something that you can't see or detect?
Well, we have a pretty good theoretical understanding of what the Higgs boson should look like and what it should do. Mm-hmm. And we can calculate from that theoretical understanding, how many times we should be creating one, how often we should be creating one, and what kind of signals they should produce. And we can then calculate, how long would we have to wait before we saw enough of them to be really sure we were seeing something. And it turns out that you need, something like twice the data we have in many models. Not in all the models, but in many models. So we can get twice the data in the next couple of years or something. I mean, not twice, but in that direction. And we should be able to finally test some of these hypotheses we've been talking about for 40 years.
So I guess my final question will be, what has been the most amazing discovery in your lifetime in physics?
In my lifetime? Yeah, I might call it dark energy. So in 1998 was the first time that it was clear that the universe's expansion was accelerating. We still don't understand that, but we know that it's a big deal, and it certainly turns a lot of stuff we know about the universe on its head. I would say that that's probably the number one.
Mm-hmm. And you had said Michio Kaku was a great communicator of science, but I have read Dark Cosmos, In Search of Our Universe's Missing Mass and Energy, by none other than you, Dan Hooper, and you are a great communicator of this as well. I thought it was completely accessible and a great read and really got my mind going, so I want to thank you for that. And
appreciate the compliment.
Sure, and you have another book as well, which I haven't read. You want to? Is it new?
It's newer than Dark Cosmos. I think it's something like a year and a half old now. It's called Nature's Blueprint, and it's about the concept of supersymmetry. So supersymmetry is one of those things that we're looking for at the Large Hadron Collider. It's an underlying principle that we think might guide ideas like force and matter and big concepts like this in the particle world. And, I wrote the book about that and about the Large Hadron Collider, which is finally operating now, and hopefully will tell me if the stuff I wrote about in that book has anything to do with nature or not.
Excellent. Well, I look forward to picking that up as well. Thank you.
I'm not much of a promoter.
No, hey, join the club. Dr. Dan, thank you very much for doing the show.
Yes, thank you very much.
My pleasure. It was fun.
Hi, I'm Dennis McKenna, and you're listening to Jeff and Jeremy on Paratopia.
Strangers in the night.
Ba 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 boo.
Ba ba booey. All right. It's time to get serious.
Yes, let's get serious.
3, 2, 1. Action.
Hi, Jeremy.
Jeff.
Hi, how are you?
Hey, Jinx.
We're here.
Let's try that again, because usually one of us gets screwed up when we talk over each other.
Okay.
So the Jeff.
So the Jer.
I guess the 2 months is up because you're back on the show.
It is not back. I will not be here next week. Do not taunt me a second time.
Wait, no, but you will be here next week, because isn't that...
That's true.
Yeah, that's the show that we're doing.
Fuck that up. Right.
It's all right. You don't need to take time off. You just need to keep announcing it so people have sympathy and, like, wish you well and stuff.
Yeah, and then I never do it. No, I am doing it. Yeah.
Dan Hooper, eh?
Yeah.
I'd like to thank Dan Hooper for coming on the show, for braving the paranormal waters.
As would I.
I found a lot of what he had to say useful in terms of just having a nice little lesson on some of the terms that we throw out or that we hear, perhaps misused or half-used correctly. So it's good to have things out there like mirror matter, dark matter. You know, you hear these things, and you're like, what's this? What's this? Well, now we know what them is. Now we know what them apples is.
Well, we do and we don't, but that's okay.
Well, we know to the best of our knowledge.
We know that they don't know.
We know that they don't know, but they don't believe us about what we think we know.
Right. And therein lies
we take for granted that they're correct. Yes. Right. But so I however, I couldn't help but notice you seemed a little perturbed at times with Dr. Dan.
What do you want from me? What do you want from me? I mean, really? Oh, well, I'm not very versed in the UFO or the ghost stuff. And then when I lay a for instance out that's been, kind of, I don't know, talked about in ufology and ghost stuff before, multiple witnesses seeing the same thing in a semi-controlled environment to a degree. Well, I don't know anything about those. Well, no, you wouldn't know anything about those, would you? And you're the scientist. Come on, man. I do understand why science doesn't look into this stuff more than it does. I get it. I got the idea that it's got this ugly face on that of the Michael Sala and the Billy Meyer and the Michael Horn, and I understand all that. But damn,
Well, and the decades of ridicule before all that from the Air Force and the government saying, nothing to see here, ha ha ha.
And I know that a lot of people didn't really care for Expelled, No Intelligence Allowed. The what was that guy's name? I can't remember. Clear Eyes is great. What was his name? I can't remember his name.
For Dry Eyes.
Right.
Yeah. What the hell is his name?
Not terrible.
Yeah, I know.
Ben Stein.
Ben Stein. Win Ben Stein's money. Yes.
Right. I mean, I watched, again, I can't watch that film without falling asleep in the fart chair.
What is the film?
It's called Expelled, No Intelligence Allowed.
Okay.
And it goes through the scientific community talking to, very high-level people in the scientific circles who have been dismissed from their jobs, from their colleges, for even mentioning the notion of intelligent design in science and in the research communities. A lot of scientists who aren't creationists and will tell you that straight to the camera. I am not a creationist. I don't mean God. I mean there's something we don't know here. There's something that seems intelligent about the design of the way things are put together. And the minute you say that in a scientific circle, you get your ass handed to you, and you're gone. And frankly, Ben talked to Shermer, and Shermer says, "Well, I don't know that that's true. That people are being dismissed from academia because they mention intelligent design. I don't think that that's true." Well, clearly, he was wrong because they are being, and apparently that the minute that you mention that in scientific circles, you are labeled a creationist. And we all know that the science is never going to go the creationist route because it's boring. It doesn't explain. It's believe me. It's just
because it's bullshit.
Yeah, it clearly doesn't pan out in a scientific manner, at all.
Well, it's not geared to. It's geared to.
It's a belief system.
To let Christians go, aha, our belief system correct.
Right.
Which makes no sense.
Right. But nonetheless, these were amazing scientists and researchers who, in the course of I think it was one very beloved professor at a university, simply put it in a slideshow. that, hey, in addition to evolution, Darwin's evolution, here's something else that's cropped up, intelligent design. And here's what that means. Doesn't necessarily mean God. It just means that there's an intelligence to the universe that seems to be organized, and there seems to be symmetry here, and this, that, and the other. And, this seems as if some intelligence was involved. Moving on, and they fire him for that. I mean, they reprimand them for that. So when you're talking about someone like Dr. Hooper, what is he going to say about ghosts? Really? That's even worse. He's going to be associated with saying that? I don't think so.
I thought it was fascinating that he is a materialist, that he is, you think of theoretical physics and you think these guys, they're in it with the Dalai Lama, that they're proving oneness and they're proving non-locality. And here he is saying, well, we shy away from non-locality. We actually don't like that.
It doesn't make
physics really means the physical, so I believe in physical processes. The end. Right. Which I think
doesn't make a lot of sense, does it?
Well,
I mean,
really
think about it.
But it's interesting because I didn't. It threw me for a loop, even though I knew that he wouldn't. I knew ahead of time that he didn't, go the paranormal route at all. But I thought at least there'd be some spark of interest in the oneness of underlying everything, the one energy. I didn't get even the sense that was. It's interesting. You would think like they would embrace this stuff because young people are interested in it, and they could at least embrace it as a learning device, whether they believed in it or not. But I guess that's not going to happen. So it was interesting to me, and he's certainly not Schirmer in that we didn't have him on to debate any of this stuff. We didn't have him on as a skeptic. These just happen to be his views. So it would be unfair to what do you mean? And grill him and all that sort of stuff.
Yeah.
That's not what this episode was for. But to your point about creationism, I guess I could defend the university in that, well, one, we don't really know what the background of that professor is. Maybe he is a fundamentalist Christian and they told him ahead of time or something. Who knows? But
they went through all of that in the film. I mean, right down to the aspect of examining what scientists were given money by Christian fundamentalist groups. Now, there's a point. Are they getting their funding from a Christian fundamentalist group, and therefore they try to sneak intelligent design in there as some kind of loophole to get Christianity back into a university setting and all? No. They went through all of these people's paperwork. So, no, this is not what they did. And all of them made it abundantly clear in this film that this is not what we mean. We're not talking about God and Jesus Christ and all of these. We're not talking about Allah or anything like that. We're talking about a certain weird organization that seems to be intelligently done. What that means, we don't know. I'm all for.
I understand the fear of that. That's how things like that seep in. It starts off as an innocuous little thing, and then it spreads. But if that's not what's going on, then that's not what's going on, and
that's not what I got from the film. I mean, and what I got from it. And again, I'm sure there's counterpoints to everything. And I'm sure people will let us know on the message board what they thought about that film if they saw it.
Or even if they didn't.
Yeah, or even if they didn't, correct. But, you watch this thing and you hear these people talking about what this boils down to is an abhorrent fear of exactly what you were just saying, that this is some loophole to sneak, prayer back into schools and teach creationism at the college level and all of that. And decidedly, that's not what these people say they were doing or talking about. They're not backed by fundamentalist groups. And it all comes down to a level of freedom in this country it's not being taken away so much as the minute that you're a scientist and you mention intelligent design, you're labeled with this, this scarlet letter, and you're ostracized from the community immediately. That smacks to me of a lack of educational or research freedom that we should have. So I don't know. I mean, when you're talking about a scientist looking at the paranormal,
or maybe it gets back to Gregory Sam's point about that deep fear of the church that scientists have because they were persecuted by the church for so long, and they don't want to bring that back,
Absolutely.
And they're being persecuted now. I mean, the science of climate change is persecuted. The science of evolution is, or theory of evolution is persecuted. I mean, So in a sense, I mean, it hasn't gone away. It's just not quite as deathy.
Well, no, it's mutated several times, but
well, except for abortion doctors, they
that's true.
reap the benefits of death.
Right? Yeah. I don't know. I mean, when you think about a scientist talking about the paranormal, I could see where that could be dangerous. Unless you're tenured. And that you don't care anymore.
Unless you're Rudy Shield. See, here, this is what sucks. We did the Rudy Shield episode, and I knew I dropped the ball there in your eyes, and I really wanted to rebound. And so here's this guy I knew was completely straight. He's part of the straight community. And it just kind of disappointed you in the opposite direction. A little too straight. A little.
A little. I mean, I still found what he had to say interesting. I mean, and you know what? I respect the view that somebody takes that ideal and strict materialist, here's my measurements, my weights, and I go by this, and that's it. I mean, you got to respect that. I just think ultimately, how do you account for what people report? And I know about the misidentifications. I know about the hoaxes. He mentioned, you get the picture of the flying saucer, and then you see the strings and all of that. And that's, well, you're only looking at one facet of this, And in my mind, and this is probably wrong, but in my mind, when you're a scientist, you try to look at a huge cross-section and focus on the stuff that seems to have some sort of substance to it. And there is some sort of substance to ufology. There's some sort of substance to ghosts. And I don't see a lot. Now, there are some scientists who have gotten involved in it to their detriment, but ultimately, this is not considered. And it's all kind of put, if one piece of the evidence is bad and you find a string or you find a smoke and mirror situation with a ghost sighting, immediately it's all thrown away. You could do that with a single case, Mm-hmm. If Joe Bob shoots a really good picture of a flying saucer and 3 out of the 4 out of the series you can find a supportive structure in, it stands to reason that first photograph is probably fake too. But to do that with an entire field of study is, I think, like you said, it's short-sighted to me.
It is short-sighted, but I understand it. I mean, I think
I do too. Yes,
there's no reason for him to think, or for anyone, for that matter, who doesn't have an interest in UFOs, to think that there is such a field of study that's going to bear any sort of real fruit. It's the stuff of the Inquirer, it's the stuff that gets poo-pooed, it's the stuff of crazy people, and right. We've railed against it. Ufology is dead for these very reasons. Yeah. So, I understand the frustration, of course, of being told, oh, this stuff is crap, to your face when you know it isn't because you've experienced it. But right. I also understand where that sentiment comes from.
Absolutely. Yeah. One can't blame science.
It's unfortunate.
Yeah.
Yeah. There it is. I got a Facebook note from Christopher Knowles about Francis Crick, who discovered DNA, or was part of the group that discovered DNA. I'm sure he didn't do it all on his own. Who says that he believes aliens put DNA into meteors and cast them about so that it will land and repopulate the universe with themselves. To which I wrote on the note saying, well, see, now this is where I think you got to say, well, who cares what Crick believes? Because couldn't it just be that things are pollinated with these giant rocks? Rocks are kind of like pollen. Around the universe, pollinating things with life.
Sure.
And well, his answer was, well, Crick would say that DNA can't exist and it can't live on a rock in space. But we didn't think DNA, we didn't think life could exist in volcanic vents in the ocean, and there are whole ecosystems down there. We thought it was too hot for life, but it's not. So the point is, even a guy who is brilliant and who has discovered DNA, I think you have a right to say, your knowledge ends here. You don't have the right to have any authority in saying aliens must have done this and rocks cannot just pollinate on their own throughout the universe and come up with some elaborate theory. I don't know. I'm throwing that out there because I think it's important to keep in mind, because we tend to think that, you throw the word scientist out there and you think, well, gee, they must know a lot about everything. And they
infallible,
they may just know a lot about their own specialty. And so I don't think there's any problem in me, the layman, saying there's a lot to non-locality. There is a lot to paradox that, in fact, my experience of the I am thing was paradox, that paradox is the root of us. So to throw away non-locality as a physicist, because it creates paradoxes and you don't want to deal with that, it is short-sighted. And to throw out UFOs and to throw out ghosts because they don't fit your belief system, while understandable, is short-sighted. And I think it's okay to say that because there is a boundary to, or there is a limit to their knowledge,
Well, I mean, and also how much of that is putting on the scientific mask for your peers? Can you not harbor a secret interest in this and then go on a show like ours and go, this really doesn't fit into my paradigm, this is not what I'm about, because you're simply saying that because you know this is going to be a public forum and you have to put on the good scientist face for your peers? You know what I'm saying? I mean, I don't find that out. Yeah.
I don't know that he's one, but...
No, I don't know that either. But, you have to wonder how many are secretly very interested in this stuff. And I mean, clearly when we had Dr. Matloff on, riding your bicycle and hearing your mother call you, that started your history into space exploration travel, right? Sure. Sorry. There's more to it than that. I mean, he felt that this had something of a paranormal venture had kind of like set him on a path to being what he is.
This gets right into Rudy Shield's story of all those scientists who were at that, what was it, a hotel in New Hampshire
right.
or Maine, and they all see the UFO, and about a third of them are like, "Oh wow, neat, what is that thing?" And a third of them are ignoring it, and a third walk away because they don't want to even have to know about it. So they walk back inside. I mean, I think there it is,
Yeah.
I mean, who does that? How can you call yourself a scientist and walk away from that? God, that's frustrating to me.
Well,
I mean, don't we learn? It's the whole Galileo's telescope. Don't we learn to fucking always look through that telescope? Why would you not look through the telescope? What's wrong with looking through the telescope?
Because it deconstructs your entire body of work.
Ostensibly, these guys are trying to figure out reality, right? They're trying to figure out the hows and the whys. And so what this shows you is that, no, in fact, we don't want to. I don't think the human race wants to figure out the hows and the whys generally. I think we want to figure out an answer that we can feel comfortable with. And then that becomes our reality. And then anything that invades that, no, we don't want that. And I think that's what this whole UFO thing, and to some extent ghosts, but I think a lesser extent, because to my knowledge, they're not doing any coordinated activity with us. But these things remind us of that. And I think the intelligence behind alleged spaceships or whatever those things are, do it on purpose. I think they're constantly calling our reality into question on purpose. And so at what point, and I think you pretty much said this to Dan Hooper, at what point do we just stop? Do we stop with the bullshit and really embrace what's going on here, or at least look at it?
Yeah. It's funny that they talk about the weirdness of quantum physics. Like, there's real weirdness here, Well, there's real weirdness right here on this show, You may not be able to measure it or take a reading on it. You might if you tried. I don't know. But again, I think it goes back to, and I'm not sure that it's all about wanting to have a handle on things. I think a lot of it has to do with ego. We've got this figured out. This is fact. This is what it is. And then something comes along that throws a monkey wrench into that and then de-evolves all of your work back to square two. You're not going to be too happy about that. And that goes everything from, physics to
But why
evolution,
aren't you going to be happy about that? I mean, he said he would be the first one to say.
Well, ultimately, he should be.
He said he would be the first one to welcome that.
Yeah, absolutely. That's the thing.
But I don't believe that. I think that that's something that we tell ourselves every day. We want the truth. We would welcome this, blah, blah, blah. But they're not. But again, I'm saying the actions of all of us are not to break outside the box,
Right.
or even necessarily to explore the box, but to create a false box within the box.
Well, don't forget what McKenna said about science. Science is the only practice where you get points for being wrong. And he said, you could come up with this amazing connective scientific practice or theorem, and then 2 years later you could write a paper on why it's wrong, and all your fellow scientists will say, "Oh, this is a good guy. He does careful work. You can trust these people. They're not flaky." But I think it's largely to get a handle, but I think there's also ego issues to be dealt with there, and grant money and all of that sort of stuff plays into it too. I mean, how many times do you send grant money to figure out what UFOs are, and then think you've got a handle, and it does something the complete opposite? So all that money's wasted. Who's going to throw more money at it again? I mean, it just becomes this endless whirlpool of nothingness.
Well, why don't we just call it what it is, which is, be it ufology or physics, a study of perspectives. You're fleshing out a perspective, and all you have to do is look to your right or to your left to have a completely other science that makes that one illegitimate. Like when you're saying they rewrite and they go, "Oh, hold everything, I was completely wrong." Well, sometimes they're completely wrong, and sometimes they're completely right from that perspective, but there's another one, which is what you learn from the difference between Newtonian science and the new physics.
Right.
One is materialistic, and the other one is there's weird stuff going on.
Right.
So we know that exists. So why aren't we just admitting that all of that is that? That there's not going to be one concrete set of boundaries. This is what this is. No, this is what this is until you pull back, and then you go, oh wait, there's more, and then you pull back again, and you go, oh well, that doesn't even work for this pullback.
Right.
It's chaos. It's order. It's chaos.
Right. Yeah. I mean, you want a good connective thread here. Look at Hopkins and Jacobs and any number of other people using regression hypnotherapy and aggressively defend that no matter what, because that fits their game plan for how they're going to explain the UFO phenomena. They won't hear anything to the contrary about their methodology of using that. Okay? But somebody comes along and says, well, here's the problems with that, and that means that all the data that you've got is highly suspect at best. Nobody wants to hear that. You think Stanton Friedman wants to talk again about the MJ-12 documents being fake? No. And he was a scientist. There's better data out there, and he just keeps doing the same thing because, again, they're married to their theories. They're married to their worldview of ufology. And I think the same could be said of science. They're married to these theories. They will not budge. I'm sure there's the Stanton Friedman of science out there that simply won't listen to anything else, no matter what. No. This is what it is, and this is what I've laid out. No matter what comes up to the contrary, I think it would take a lot to make somebody break in science from what they think is right and wrong.
Mm-hmm. Well, and to that end, I'm at least grateful that, I don't know, he didn't say it, but I just had the feeling that he might have wanted to hang up a couple of times, Dr. Hooper. I don't know. Yeah. So this wasn't necessarily his type of show to do, and
right.
And he did, even if he did recontextualize some questions, I think he basically embraced the questions and ran with them.
Yeah.
So yeah. I thank him for that. I think that's...
Yeah, sure. Thank you for not hanging up on us.
Thank you for, yes. Thank you for affording us the respect that we afforded you.
Right. Right.
Thank you for not hanging up on us. Yeah, well, this is what we got. We've been saying we want to bring in quote-unquote mainstream people from other fields.
Yeah.
And when you do that, of course, you run the risk of bringing in people who think that everything you stand for is completely wrong.
Well, it's to be expected, and it's also to be expected that I'm going to kind of get in their face a little bit.
But is it fair if they don't expect that? I guess we should put a disclaimer, warning. Jeff Ritzman might get in your face about that.
No, and I don't think I did that. But it's I just want to know. I was curious to know, what is your thought process when I tell you this?
Right.
And there isn't a good answer. Really, aside from what he gave, which was, like a hoax scenario. Okay. That's the thought process.
Well, I think the answer is I haven't really thought about it because it's bullshit.
Right.
I think that would be his true answer. If he didn't care what we thought, he would have just said that. Yeah, no, guys, I actually think it's all bullshit, and so I don't think about it that way.
Okay, fair enough.
And I say, why wouldn't you? Of course. And then that gets again, it circles right back into the whole problem of how ufology has screwed us again.
Yeah.
It used to be the government. There used to be scientists who cared, and then they were warned off, and they were made laughing stocks of, and all of that. And then
there's a picture of Chet in his backyard with his pine trees.
Right. Yes. Yeah. And then it just was like that was like unleash the goofs.
Yeah. And what scientist is going to look at that and go, now that's interesting?
Right.
I'll tell you, the only scientist that's going to find that interesting is a psychologist. They're just going to find that interesting. Yeah. Why the fuck would anybody in their right mind believe this shit?
But we're living in it's the dog who doesn't need a collar anymore or a leash because they know their boundaries. That's what we are now. That's what we're living in. Like we don't need we don't even need government disinformation agents to infiltrate UFO organizations.
No.
We'll take it from here.
Right. We got it. Yeah. That's okay. We got it. Yeah. Yeah, absolutely. There's no need for. That's why I laugh at anybody who, comes up with this big cover-up of the U.S. government, And I reconnected with, interestingly enough, I didn't even tell you this before the show. Oddly enough, when I go to take a break from the field a little bit, for just a short time, my 10 years gone research partner writes me.
Oh, you did?
Hey, man.
This. Yeah.
Hey, man, I'm back in. Great. Give me a call. And we were talking about this very thing. It's like you hear all this stuff about recovered discs and all of this other stuff and government informants, and they're covering it up, and it's all really. Are we not past this now? Please, come on. No, we'll take it from here. That's a perfect.
Was he sending you that stuff?
Well, I mean,
like he believes it?
No, he was saying, I made the point. I said, everybody's so caught up in that still to this day.
Right.
And 10 years ago, he and I were throwing out these whacked out theories of focus of intent and expectation and, some other, some Jungian type thoughts at this stuff, which has been we weren't the first to do it by any stretch, but we were thinking about it more so than nuts and bolts stuff. And that's kind of where my wife actually knocked on the door. It's time for dinner. That's my love.
Yeah, it's time for dinner.
Okay, it's time for dinner.
It's the hooded man.
It's the hooded man. Yes, yes.
Hi, Lisa.
We're recording the show. We're broadcasting, numbskulls. Yes.
Very professional.
Right.
This
Lisa
is
Richmond,
show,
ladies
so
and
don't
gentlemen.
even bother with the 3, 2, 1.
That's right. My lovely wife. So, yeah, I mean, that was one of the things that came up, and we kind of snickered. He's like, yeah, those government retrieved discs. And we just started laughing about it. I was like, well, that's taken a huge quantum leap forward into, Chet in his backyard in his Bermuda shorts and his ball-hugging, jockstrap hanging underneath the pine trees. And they're calling it an alien who's in excess of 8 foot tall. And
I want to know, I was at, God help me, I was at the Open Minds Forum.
Oh.
I just wanted to see what was going on. Man, did I. I mean, it's like you take the worst and then you bury that in sediment, and that's the Open Minds Forum.
Yeah. Yeah, apparently I hoaxed the O'Hare sighting.
Is that right? Oh, well, I missed that thread, but
yeah.
I did see where there's a thread. Did disclosure already happen? So the way they're getting around all of these disclosure dates that came to pass with nothing is to say that the media was brought into a room, they were told all of this stuff, and then they were told or just didn't want to go public with it. I don't remember how that ends. I mean, who cares how it ends? The setup is bullshit. So, but it gets me to thinking that, I mean, I'm always trying to look for the cup being half full. I'm always trying to be, like, hey, Bassett and these guys aren't lying to us. They're just being misinformed. But I got to think at that point, somebody is sitting in a room thinking up a lie to cover their asses, and that's how that gets out there. So I think that the whole disclosure movement, I think they're all just liars. I don't think they even have informants. I think all of that is a lie. That's my new take on it. I'm just going to... The cup is completely half empty at this point, with the exception of Sean and Clay Pickering, who I really do think are being strung along by some bogus informant as a joke, and they're just too brain dead to get it. I think a lot of these people just completely lie.
I think it is a textbook look at the Dungeons and Dragons of adults. It's a story to follow, to participate in, and it's folly. It's senseless folly that has a UFO thematic laid over the top of it. I mean, that's what I think. A lot of that stuff, the Serpo junk and all that, that's all an ongoing soap opera. And this is drama for people who want drama and want to be able to interact in that drama. That's Dungeons and Dragons for adults, And saying that disclosure happened. Did disclosure happen? That's like, who are you, Julia from Lost? It did work. I mean, really? I mean, no. It only half worked, or it didn't work at all, or everything's just thoroughly fucked up. Pick one.
Do you think Michael Salla got that photo from someone who was like, I mean, maybe it doesn't even matter at this point, but here are your options. He was given a photo and was told, this is an alien and it's Chet from your backyard. Right. And he just went, yeah, that could be. Well, I'll put that on the net and I'll make some money on the Examiner from all the hits I'm going to get. Or he just found an old photo and put it on there and lied. I mean, really, what are the options here? I can't imagine anyone really sending him that photo, with the exception of Paula Harris, because she's a, moron, who does believe that there are Italian aliens running around in Italy and has presented those photos. So I could see her maybe getting this photo and giving it to Michael Salla or something. But I don't know.
It goes back again.
Yeah, I mean, do we know what the origin of such things are? Is anyone held accountable in disclosure? This is the thing that gets me. The disclosure movement wants the government held accountable, and they want disclosure, and yet they won't disclose any of their sources, and they're not held accountable for anything they say.
Exactly.
Or present. Where does this picture come from?
A desperate need to believe.
Who cares? I mean, but it's such a dumb picture. Yeah, who cares?
Well, it's ultimately interesting from a sociological standpoint. Where does this shit come from? I mean, who believes this? And you might make the supposition here that Salla is so desperate to believe, or so desperate to get his hands on something, that if somebody that he feels is a decent person comes up and says, I feel like Kramer from Seinfeld, believe me, please, it's real, this is it, that he goes, you know what? I'm in. I mean, you got to wonder, does that actually happen? I mean, does somebody actually, work to establish some kind of credibility with somebody like Salla, and Sala's so anxious to believe anyway, that when they go, this is it, I'm telling you, that look at the size of this guy. That tree next to him, that's 20 feet tall. He's a giant.
See, I'm dying to sneak into...
That where Salla doesn't go, where would you buy pants for a man that size?
Right. Well, that's
stylish pants. By the way,
he's got to have an engineer look at that photo and tell him.
Right. You don't seem to understand. Those pants. You think those pants are patchwork? No, those are tents. I mean, I don't know.
All I know is Clinton is in a hospital in New York right now. I would love to sneak into that room and just say, "Hey, Bill, have you ever met a Dr. Stephen Greer? Have you ever heard of this name?" I would love for him to go,
what's
don't
wrong?
know who you're talking about. I don't know. I think it's some sort of heart issue.
I hope he's okay. Best wishes to President Clinton. Yeah.
And me selfishly just want to ask this question. But yeah, best wishes to President Clinton. I just can't imagine, like, even if, I'm thinking about Greer, even if Greer at the beginning knew somebody in the Clinton administration or any of those administrations that he still touts to this day, like an actor listing some high school credit on their resume. I was in the Wizard of Oz once. So that was high school, dude. Could any of those people really look at his ads for become an ambassador to the universe that he's running right now in UFO Magazine and not call him up and be like, I'm sorry, Dr. Greer, I've got to tell everyone I've never heard of you. I've got to completely disassociate myself from you. Does anyone really think that wouldn't be the result of his turn as, ambassador to the universe? So I don't believe he had any of those contacts. If he did, they're long gone.
Why does Jeff want to take a break? I mean, God,
you think
damn
Podesta's like going, yeah, I can't, ambassador to the universe, eh? Yeah, let's call that Stephen Greer back in here. Let's have that meeting he wanted to have. Now that I'm head of the CIA, let me give him all of the information so he can disseminate it among his people. That's the man for me. Yeah. No, that's not going to ever happen.
Nor is the working with a was it G for government or something, and for on disclosure. Like if you were head of some major European entity, country, whatever, you're going to call Stephen Greer to help you. I think I'm calling Jacques Vallée. I don't think I'm calling Stephen Greer. God.
Wrong field of expertise, doctor.
Right.
Call me. I'm an emergency room physician. I'm sorry, what? Oh, yeah, I'm an emergency room physician. You can trust me with disclosure. Right. I'm also an ambassador to the universe. I've got my card here that I made.
Right.
Unbelievable.
As he drops his Megatron harmonizer on the floor when his wallet opens. Whoops.
I mean,
let me get that.
I still get comments on my, I've got the Dr. Stephen Greer impressions up on YouTube.
Oh, yeah.
And I still get comments to this day defending him and saying, this is awful. You're full of shit. You're terrible. This is a good man. He's telling the truth. It's like, really? What does it take to wake people up? I guess nothing.
Nothing. It's useless. You can't forget it. You can't. It'd be easier to turn science onto this stuff than it would be to
what we're doing. So good. I'm glad we went that way. Gone that route.
Yeah. So I don't know. I mean, it's pretty pathetic, and that's I would say that's a good 30% chunk of why I need to walk away, because it's just like, at least for a couple of months, just walk away and go, no, I don't want to hear any more. I don't want to see Chet in the backyard wearing his ball-hugging shorts and saying he's an alien, when in all likelihood, if Chet's photo gets passed around the net enough, wouldn't Chet come forward and go, hey, that's me. I'm not an alien. Unless Chet's dead, and then Chet's not coming forward. I mean, it's as bad as Graham Bethune. Does that ring a bell to you?
I know the name.
Graham Bethune was I think he's passed away. And I mean this. I don't mean any disrespect to the dead here, but
with the exception of Graham Bethune.
No, I don't mean any disrespect to anyone, but this is a guy who came to a local MUFON meeting several years ago, who I really wanted to go see talk. And this was a guy who, if you look him up on the net, he was an airplane pilot and shuttled a lot of very important people, including presidents, I believe, around. And he had a major UFO sighting over water. The thing came up out of the water and followed them. And I had seen him on several TV programs. I thought, wow, really a credible guy. Seems like a very open guy, telling you exactly what happened, exactly what he saw. It seemed like a really good case. And then when he came to speak, one of the first slides that came up was Valiant Thor. You've seen that photo, right? It's an old black and white photo. Mm. And yes, this was a man from Venus. And I have also talked to women and men from Venus, and Adamski, and all of this just went on and on about all this really like old style contactee stuff. Like they're from Venus and Jupiter and Saturn. And I was just like, whoa, what about when you were flying the airplane and you saw that thing? And what about that? Can't you? No, don't say anything else. And then he brought up a slide that it's this really amazing shot of all this smoke, and there's this panel disc. It's lit up, It's got all these wild lights flying around it. And when he brought that up to screen, he says, this is a man in, I don't remember, Tennessee or something, took this series of photographs of this amazing craft. And this is from Venus and this, that, and the other. And, we've had this analyzed 6 waves from Sunday. And I'm looking at this thing and I'm going, yeah, that used to be in a warehouse in Baltimore. That's a stage prop. It's just so, it's this, you don't really know. I mean, people see Greer on TV, and I think that's the only exposure they really get to him. And on TV, let's face facts. He comes off, he's very media slick. He knows how to talk, and he seems intelligent. Go see him speak. That's when you get the real measure of a man. And you'll hear that it's batshit. You cannot go off a soundbite. I don't even think you can go off a book. You go and see these people speak and you'll get the real story. And so Graham Bethune, at the end of the night, I was like, I don't know whether to believe his sighting or not. I mean, with all the other crazy crap he just threw out at us, all of this thoroughly disproven stuff that he believes, I mean, what do you say to the original thing? What do you say to that original sighting? I say, I don't know to believe that or not. It doesn't surprise me that people still defend Greer. It doesn't, because he's not an idiot. He's not an idiot. And he knows how to slip things in a really innocuous way that you don't realize until you walk out and, it's like pissing yourself in a dark suit. It's like, oh, did I just piss myself? You know what I mean? It's like it doesn't hit you until you're out. You're like, wait a minute. Did he say he held pictures of an alien baby? No. Did he piss like root beer? And there you are. So, I have lasagna waiting.
Ah, la lasagna, as our good friend Weird Al Yankovic would say.
As Garfield would say, I love lasagna. Yeah.
Well, another episode, another disappointment. No. No, I think as we've just demonstrated, this is exactly why Dan Hooper will never embrace UFOs or
right.
ghosts.
Yeah.
And probably why we shouldn't, except we see them.
Yeah.
That's the problem.
Yeah.
And then the other problem is that these people claim they do too. Wah, wah, wah.
Hi, Chet.
All right. Well, you enjoy your lasagna.
Yeah.
And I'm going to go back to being cold and alone.
Okay. And I'll see you next week for another episode of
Paratopia.
Ding, 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 ding.